V. So last time we talked about the bisection algorithm. So this is to get the root of a nonlinear equation, which is written as f of x equals 0. So we would like to see the value of x where the function crosses the x-axis. And in bisection method, we have to start with an interval in which on one side of the root, we have the negative value of the function, and the other side, we have the positive value of the function. So we find out a midpoint, and then we see at midpoint whether the value is positive or negative. So then we decide, like if the value of value at C is less than 0, then we have to further look for the root between the interval C and B. So from A to C interval, it needs to be discarded. So for example, the first C appears here. So now there is no need to find the root in this interval. This must be discarded. And now the next search would be done between this C1 and B. And after that, we will calculate another mid value. And after this value, we discarded this interval from C2 to B. And then the root was look for, sort for between the interval C1 and C2. So we developed the algorithm, and we also implemented that one in Fortran program. Today, I would like to develop a generic function from the previous program that would have such a structure that it would be bisection. It will take on a value A and B such that on these 2 points, the function values are going to change their polarity. So the root needs to be located between the two. And then I will also make it intelligent enough to look for a certain criteria. And also it will be able to read the function f of x itself, so that I can integrate this program, this function, with any problem that conforms to the shape f of x equal to 0. So irrespective of f of x, it will become independent, and f of x can be dynamically provided from the main program, right? So that's my objective in this demonstration. So let's see our program one more time. We build that one as program bisect, implicit none, real S, A, B, C, epsilon, error, F. So this is the function reference over here. Then epsilon was defined, so we will make it generic. Then error was defined, and then A, B were defined. So there were several prints. There is one print statement. Then midpoint was calculated. Then we made the check. F of A times F of C is greater than 0. So if it is a positive value, it means both are either positive or both are negative. Then the update of the interval, like C has been set to A, otherwise B has been set to C value, and the error was calculated, and then there is print statement and go to 20 and bisection. So over here, the function f was defined over here. So function fx, x square minus 2. So our attempt was to get the square root of 2. Now, the generic structure, if I would like to change a new function, so I have to only change this function. If I would like to tailor it to another problem, I have to update the value of the function. I have to change here. And also I have to change the initial approximations for the interval where the function has a different polarity, opposite values, opposite sign values, and the epsilon. So it means these things need to be updated, right? So let's copy them, and I write it in my library file. So this was the part of program which begins with the value of epsilon and what was above it. So above it, there are the definition of these things. So even we can take all that over here. Well, we require all that over here. So I pick up all that. And in the library, I paste all that. I would like to allow the print statement. Therefore, I would prefer the structure of a subroutine. So I write here the word subroutine, subroutine bisection. So it should be able to read a value of a value of B, a value of epsilon, and it should be able to read a function, right? F of x, and then it should return the value x root. Okay. So now let's see the things. Okay. So implicit none, I require the, okay, A, B, C, epsilon error, right? So I will get these values from a main program. So I make these two as silent. So I have made them silent. Initial values, they are not required. I will get them from the main program. Okay. So print values. Okay. Error needs to be defined. Okay. Then C, okay, this will be calculated function. Let's see whether it is going to read the function. Error. So everything is fine. And finally, I have to get a root value. So I define the x root value. X root is equal to the value of C. The final value of C is the x root. And then I have to have the statement return, right? This is the root value. This has been stored. Now I have to write the end subroutine bisection, right? So a subroutine has the input and output arguments written all here, right? And okay, so there is the thing F that it should be able to read. So since it's a subprogram, it requires the mention of function as F. Okay. So now let's write a main program in which we will define the function. So okay, let's connect it with the bisect.for. So we have the real function. Now this function is going to be called in a subroutine. So I use the keyword external f. External f. Now I have a function, and I now define the different variables like ax, bx, and well, cx is not required. Okay. So epsilon. So over here, I say epsilon error is is okay, right? Just making them distinct from the main, from the subroutine things. Okay, so for the same problem, let's define ax equal to 0, bx equal to 3, right? And epsilon is defined as 1 e raised to the power minus 3, right? So now let's use the subroutine, and I say call subroutine is bisection, and it should contain the A, B, then the epsilon is the convergence criteria, and it should read the function. Well, we have to see the consistency of the function. Okay, f and x root needs to be uh, get as an output. So x value, which is the root value. Okay. So the values will be given to the subroutine, and they will be returned. So now I write the print statement. Print statement. Uh, the value of root is okay, x value, right? And x value must be defined in the main program. So x value, okay, right? So it will, as the program approaches the call subroutine, so it will pick up the calculation sequence from the CF lab. So let's see. I'm quite hopeful. The function is defined over here. You have the library function bisection, right? And it also marks, okay, exceeds the 50 lines. So 50 for CF one course in 2026. So first 50 of computing fundamentals course in 2026. It has been completed in this inning of the 0th semester. Okay, let's compile the two, and let's see whether there are some errors or not. So I write here CMD. Okay. Okay, the black screen. Okay, properties are allowed. So 20 or 24 would be fine. And font, console, OS, layout, colors. Okay, so I prefer the background as white and screen text to be blue. Okay, it's here. I have to get to the directory. So fearless will be great. Directory D. Okay, I have to see the subjects. Okay, and from the subjects, it is the scientific computing. With the tab, I'm moving towards, oh, I lost that one. Scientific computing, and I have found that this has become sensitive to spacing. Okay, I'm rightfully there. Then there is the folder G77. Now I can directly get to there. Okay, dir, it contains the files by section. Yes, bisection, bisect.for. Earlier file was bisect.exe that needs to be updated, and CF lab had also been updated. So I delete the bisect.exe, the old compiled file. Now I compile again G77 bisect.for and cflab.for -o to a new file, which is bisect.exe, right? The library contains the function by subroutine bisection, right? And which can also read the function, right? External function defined in the main program. So, okay, this is the subroutine, right? Okay, so the dangerous movement. We are very scared of errors, right? So errors requires correction, right? Okay, so subroutine 56 invalid declaration or reference symbol x root. Okay, x root was not defined over here. So real x root. So during the process of demonstration, I was lost. Okay, so let's see that one. Oh, it seems there are no errors. It's a great moment of joy for the faculty. So bisect.exe. Okay, some music in the background also celebrated that success. Okay, we got the answer. We got the answer. The root is 1.414. Now, this is an amazing moment of celebration. Computer has accepted that. Now, I make the more generic one. Please hold your claps. Okay. So let's define another function. Okay, let's define another function. It's amazing. So let's define another external function in the seventh column, like function function g of x, function g of x, and implicit none. I'm in a hurry now. Real x, real g, and I would like to calculate g of x equal to sine of x, right? And I would like to find its root between the interval in the interval minus pi to pi, right? So I expect a zero answer must be returned by the program. So there will be n function g, right? Okay. There was objection of saying g of x, objection sustained. So real f, g, and external fg, right? So real value of x, sorry, x value, print asterisk. Okay. Now for the next problem, I define again ax is equal to minus pi. So I define here a is minus pi, the left point of the interval. So I define it as 4 times a tangent of 1.0. This is a value which is minus pi, and I define b of x as it is minus 1 times ax, right? And then I keep the epsilon same. So now I call bisection method again. This is for the second function. So I write ax, bx, epsilon, g, and I would like to get x value again. So print the value of root is x value, right? Right. So minus pi to pi. So behold, I have to again compile because the main program has been changed. Oh, g of x. Oh no, it should not be written as somewhere. Okay, this g of x was a problem. it was automatically typed by this text editor. So sometimes the primitive text editors are fine. The advanced ones create errors as sometimes. Okay, so we are ready to enjoy the success. Roots of two functions, where the function is being read by our subroutine, right? So program has been compiled. Everybody and computer is ready to celebrate the success. Bisection.exe. Oh, bisect.exe. So writing names is required. CLS, typing mistakes. Wow, the root is, first root is 1.414, and the other root, oh, it moved to it has found some trap. Sine of x function. If it is 0, so sine of pi is 0, sine of minus pi is 0, sine of that pi is also 0. So that is the numerical trap. Let's correct that one by defining it pi by 2. Okay. So this is kind of a logical error that the program has computed something. It is correct for one function, but it is generating error for the other function. It means you have to see the function one more time, right? You have to see the behavior. So it is 2 times. Now it is pi by 2. This is going to be the right domain. So our first condition was not satisfied. So this is pi minus pi by 2 and the pi by 2. So if you see the shining stars in the output, it means something has been in the black hole, right? So there are some undue shining of the stars. So actually they have lost their value. They have been trapped in a black hole. So strange values are also important. They give you a sign that something has got wrong. So G77, one more try. It is good that the computer is witnessing the errors and the graceful attempt to fix them. Okay. Bisect.exe. Some of the students are compiling the programs without computers from their voice. Oh, great. The root is 00. It is accurate up to 3 decimal places, right? So it has looked for the 0. So it is true for 3 decimal places. If you increase the criteria, so no problem, to -6. So program is in rock and roll state. 10 raised to the power -7, right? So 0 has been found. So it is point. It has 6 zeros, right? This is the value of the error, and the root has been found like this, right? In C value, you find that it has approached a 0 value to 3 decimal places, 4 decimal places, and now the format is inadequate to show you the 7 zeros, right? So you can settle that one in the statement, and for that one you have to correct the program, or add, not the correct, you have to update the program in the print statement. So it is F7.5. So if I set 10.7, right? And I will set that one to 10 so that it show up correctly. Okay. Compile and run. It is like prepare, move forward, attack, and return. Right? So up to many decimal places, the root has been defined. So it has been printed in the in that exponential notation, right? So Let's stop at this point. I have demonstrated how we can use a, a function as an external function that can be utilized in a subroutine. So two functions f and g were external functions. They were defined at the end of the function. And by external, it means now they can be called in, in a subroutine. So the subroutine's function, subroutine structure become generic. You can write it like you write in mathematics as f of x. So see the structure one more time. Uh, the subroutine bisection. Yeah, subroutine bisection. It takes on the input values a, b, and the convergence criteria, and the function is itself. So that's the structure of professional libraries, that the functions are so generic that you can integrate them with your defined functions in the main programs. You define your desired functions in the main program and you integrate them with the standard library functions and get the results. So take a deep breath. It calms the mind.